Good morning. My name is Flavio. I'm moderating the session on behalf of Dr. Walid, which could not come. This is the second panel, and in this panel, each country from the ENEPLAN project will present a study case. We start by University of Siena, and my colleague Ricardo will present the first presentation.
Here we are. Thank you, Flavio. I'm glad to be here and to visit Beirut and to be part of this amazing ENEPLAN partnership. And it was very good to work with you during this project. I come from the University of Siena, Department of Environmental Sciences, in a group, namely Ecodynamics Group. Just to introduce ourselves, I will tell you a story about three projects we have developed in the last years. One is the Siena Carbon-Free project. That is a project we started in 2008 because we have an expertise in environmental accounting and greenhouse gas inventories, and we started doing the greenhouse gas inventory of the province of Siena. And in 2008, we figured out that the emissions provided within the area of the province of Siena were close to the carbon uptake by local ecosystems. That means that we were very close to a condition of carbon neutrality. 70% of the emissions within the province were covered by the carbon uptake by local ecosystems. So we started the process together with the administration, and we achieved the goal of carbon neutrality in 2011. And probably the province of Siena is, to our knowledge, the first case in the world of a carbon neutral area that is certified ISO 1464. That is an international standard for greenhouse gas inventory. So this project is based on the relationship of three main bodies. One is the University of Siena that made the assessment, the greenhouse gas inventory of the province, a control authority that has the role to regulate and to control that the assessment is made in compliance with the ISO rules, and then the local authority that made a lot of actions to achieve the goal of carbon neutrality. Most of these actions concern energy saving through the regulation of heating systems within the province of Siena, and the renewable energy supply. Currently in Siena, more than 100% of the electricity demand is covered by renewable energy. 90% comes from geothermal power plants. Then we have photovoltaic, of course, and a little percentage comes from a waste-to-energy plant. The area of the province of Siena is mainly covered by agriculture and by forests. So there are a few cities. One of these is Siena, so it was quite easy to achieve the goal of carbon neutrality in this area. The point here is that Siena itself, the city itself, is not carbon neutral. The city is, the urbanized area, and especially we made an assessment concerning the historic center of Siena, that is an heritage, a UNESCO heritage. So you can do almost nothing within the city center. So we tried to make a vision, to provide a vision on how to make this historic center carbon neutral by 2050, for example, so in the long run. And we made first an assessment of the current emission within the city center that are based on heating and cooling systems in buildings, transportation, waste production, etc. We made a first scenario that we call a short-term scenario, in which we hypothesized some actions to improve the building envelopes and for energy saving in buildings especially, and a provision of electricity by photovoltaic panels. And then we hypothesize also a long-term scenario in which we figure out a fully transition of the system to electricity that is fully provided by photovoltaic panels. And to see if this scenario is feasible, we made a survey of the available flat roofs on commercial and industrial buildings just around the city center. So we created this kind of what we call a solar belt all around the city center. And that surface is available. We have found 24 hectares of flat roofs all around the city center that can host, potentially host photovoltaic panels that can potentially supply all the electricity demand of the historic center after its transition to electricity. So this is the scenario we can have, the vision we can have for Siena in 2050. Third project, well, this is an image of how it works. There is the historic center up the hill, and then there are the flat roofs of the commercial industrial area here and here. Third project, we are involved in a project, namely Citizen. It is an FP7 project funded by the European Union, of course. And we are in a group of experts that travel throughout European cities to promote the decarbonization through workshops or roadshows that are some kind of living labs in which we work with local people, local authorities, local stakeholders to promote actions towards decarbonization. So the aim of the workshop is to figure out possible solutions, including renewable energy technologies and other integrated measures to start this process, to kick off this decarbonization process of European cities. And my role in this case is to make an ex-ante evaluation of the possible effects of mitigating measures to achieve this goal of carbon-free urban neighborhood. We made an experiment in Sevilla. Our Sevilla friends will be happy for this, in the neighborhood, namely Tiro de Linea. And it is a neighborhood of 14,000 people, and this is the neighborhood. Usually the workshop takes place in 1 week. So we arrive on Monday, we visit the place, then we have to figure out a plan, an energy plan, to design it, to assess the possible effects of this energy plan, and we make a presentation on Friday morning. And usually to make this assessment, I start from the single functional unit, that is the single household, the single family within this mostly residential neighborhood. And in Sevilla, for example, that is quite similar to the, of course it is a Mediterranean climate, so it's quite similar to Italy, to Lebanon, and to our countries. I've seen that, I've collected some data, some information. We have seen that the electricity demand in houses is around 2 megawatt hour per year, and also the heat demand is very low in our countries, is 1.3 megawatt hour per year. And also I considered the use of private cars, the waste production, and the water use. And finally, I figured out that I assessed the impact of one single household, that is 5 tons of equivalent carbon dioxide produced or emitted into the atmosphere in 1 year by every family. Well, since I have to talk or to interact with people during these workshops, what does it mean, this number? Well, it doesn't mean anything to everybody, you know. It has no meaning. 5 tons. It is low. It is high. It is very high. We have no idea of that. But just to visualize it, we can say that in order to absorb 5 tons of carbon dioxide in 1 year, we would need a forest that is big as a football field. So this is the forest we need per each family, per each household in this neighborhood. This is quite impressive, right? We would plan cities in which each neighborhood has a backyard that is covered by a forest and is big like a football field. It's really impressive. So this is in general a common situation in most of Europe. So it's something that we need to manage. We made the same at the level of the neighborhood. The neighborhood is made of more than 5,000 households, so I assessed the impact of the neighborhood. What you see is in scale, so the squares represent the forest land grabbing of the neighborhood. That is the carbon footprint of the neighborhood expressed in terms of surface of forest land. It is 20 times bigger than the neighborhood itself. That's the impact of the neighborhood. The colors represent the blue is electricity, the orange is heat demand, violet is waste, and how is it called? Chan is the mobility. This is the starting point. This is the challenge we have to face every time we manage urban neighborhoods. And with other experts from other European universities, we designed possible integrated solutions to decrease this impact and bring this carbon footprint to zero. And what you see now is what is going to happen. First solution is about our behavior. It's about greenery of houses, shading systems. And you see the Pac-Man game represent the way we eat the forest land we need to compensate the impact. So this is the first measure. Then we have thermal insulation of building envelopes. Then energy saving by changing the lights, for example, or even decreasing the air conditioning, like in a place like this, that we all feel cold because it's too strong. Heat pumps for heating houses. When you see the ghost appears, it means that there is a decrease in fuel demand for heating, but there is an increase of the demand of electricity. That's why the ghost appears. And then, again, heat pumps at the neighborhood level, PV panels on houses, PV panels at the neighborhood level, and other solutions for sustainable mobility, bike sharing, bikes to school, electric tram line, and a fully transition to electric mobility that also requires an increased demand of electricity, the ghost appears. And finally, other PV panels and energy generation at the street scale, a better management of waste at the urban level, and the final carbon footprint can be finally compensated by urban forestry. So when we deal with scenarios, with action plans, we have seen before that at the national level, what's the vision we have? Well, this is an example of the vision we should have, and how feasible it is if we start now to change our cities, our neighborhoods. For example, this is something that we can figure out also here in Beirut and everywhere in the world. It's something that concerns our life, our neighborhoods, and our cities. Well, this is a C-map describing the process, but it's done. Thank you very much for your attention.
Thank you, Ricardo. We have a question and answer at the end of the panel. So we move to our next speaker, which will be Daniel from University Pablo de Olavide. Oh, Josefina. And Josefina, great.
We do it in our Okay, first of all, we would like to thank the university, the American University of Beirut, to be welcoming us to this beautiful country, especially Yasser and Petra. For our presentation, we have used, which is one of the bases of our project, ENEPLAN project, which is concept mapping. I am going to share the presentation together with my colleague. We both work for UPO, it's Universidad Pablo de Olavide de Sevilla, and his name is not written, but his name is Daniel Ayala Serrano, and he is an architect. So the result of using CMAP tool and us being urban planners is this. So you cannot really read anything and not really understand very much. But we will try to explain it. The idea, we agree very much what the I think is the dean of the faculty was saying in relation to the need of integrated systems and the need for sustainable energy planning. This presentation is about what we are doing in Andalusia, what we are doing now, okay, that is going to be presented by Daniel, and what was said by someone else, wishful thinking, what we are supposed to do in the future, that I'm going to try to explain it. Our policy, or energy planning policy, is based on the Andalusia energy strategy. And one of the main instruments, maybe I can play a bit with that. Okay, oops. Okay. And one of the main instruments is the SEAP, that most of you know, Sustainable Energy Action Plans. This is very much related to, of course, it couldn't be done in a different way, with the 2020 European Union strategy. And it shares objectives with it in relation to reduce 20% of greenhouse emission. In the case of Andalusia, is 30%. Increase energy renewable consumption, in the case of Andalusia, is 35%, and achieving 20% of energy savings, in the case of Andalusia, of a region. We have a decentralized system. I don't know if you know Spain. I mean, you have here in Lebanon a centralized, we have a decentralized system, which each region, under the umbrella of the national policy, develops different autonomous policies, let's say, okay? So in the case of achieving energy savings, our strategy aims for 25%. So Daniel is going to explain a bit what is the situation now, which is the impact of this policy, and which are the measures that has been implemented, and then I'm going to talk about the near future.
So thank you, Josefina. To know about the importance of the Sustainable Energy Action Plans, we need to start talking about Andalusia energy strategy. So, because the strategy defines what is the Andalusia energy model that actually have. The Andalusia energy model is based on use local resources like biomass or wind power or solar energy, and also to promote renewable energy resources and accelerate development of low carbon technologies. For example, we have a case study, a success case study with Abengoa, it's a huge company, to develop on ED, so that the facts, the actual statistics about the Andalusia energy models has been achieved because we have two previous plans, the energy study, Andalusia Energy Study 2000-2007 and Andalusia Energy Study 2007-2013. The statistics are the facts that are Andalusia actually produced the 60% of the thermoelectric energy in Spain. Also, Andalusia is the fourth region on wind generation in Spain. We have put a lot of effort in the renewable energy. So the CEPS is an instrument of the Andalusia energy strategy. It's one of them, but it's the most important because it includes measures like improve local public buildings and infrastructure, or encourage sustainable mobility, or support renewable, local renewable energy production. Sorry, but this measure also can be supported by other sectoral urban plans like mobility or grants or other that Josefina explained after. So the impact of the SIAP in the Andalusia energy strategy is that Andalusia is the region with the highest number of municipalities with PAEs or SIAP in the Europe. Or other statistics, other quantities impact like the municipalities which since the SIAP or developed the SIAP have some consumption of electricity is 55% lower than the other municipalities that don't have sustainable energy action plans. So the urban transformations, Josefina, explain.
We share very well the time. We are very efficient in using the time. As Danny was saying, these sectorial plans, among them SIAP is one of them, has helped us greatly for a step forward about integration, about those integrated systems that we were discussing before. Basically, they have feed up what is the main tool for sustainable urban policy, urban development in Spain and in Andalusia as well, which are the integrated and sustainable urban development strategy. This means that 1.4 million euro is going to be invested in, is being invested in Andalusian cities, and one of the main topics that are being developed is what is called thematic objective 4, related to economía baja en carbono. Okay, mobility and energy efficiency actions. Those actions has to demonstrate that are connected to other 3 thematic objectives from the European 2020 strategy. Those are poverty and social cohesion, use of revitalization of natural and cultural resources, and smart cities and technology. So those tools, that this instrument actually puts together, integrates different policies into just one planning instrument. And for us, that's a huge step forward, also because it comes with money and not just with wishful thinking, and helps cities at the local level to implement those policies and those measures. Hopefully, this is going to be taken forward. Well, not hopefully, for sure it will take it forward, but this is the future. The idea is that for the next programming period, starting in 2021, a new objective, a new political objectives, they call it now like that, life, climate, and environment, is going to be the objective, which will be the base of this policy at the European level. And that means, in the case of Spain as a whole, and I think in the rest of the countries as well, that 6% of the European Regional Development Fund is going to be invested at the European level in this instrument, which take into account the sustainable and integrated policy, including energy planning. In that sense, the next tool that is built up in relation to, okay, that doesn't move. This is built up in relation to the Sustainable Development Goals is the CCAP, okay? Which actually, can you follow with all these movements? You get a bit lost, okay. The SICAP, which is the sustainable, okay, bigger, like that? SICAP, which is the Sustainable Energy and Climate Action Plan, that adopts a jointly approach to tackling mitigation and adaptation. That's the step forward, and that's the step forward that we hope is going to be translated into the urban, sustainable and integrated strategies that are coming for the next programming period, 2021-2027. So I think we are on time. Okay, great, thank you. Maybe I will give you a comprehensive look of the CMAP.
And we move to our last presenter, who is from University of Algar.
Good morning to everybody. I would like to express my gratitude to AUB for the hospitality and also for all ENEPLAN partners. It was an honor for us to become part of this project. Now I'm going to present this presentation that was made by the Algarve team, me, Flavio, and Marisa. The statistics for the energy usually presents the residential and the tertiary sector of the final energy consumptions. This sector is known as the building sectors because these activities take part in the buildings. This consumption is about 40% in EU and about 30% in Portugal. The solution is the energy efficiency and increase the renewable energy. Also because they are a tendency to increase this energy due to comfort, thermal and more exigence of the people of the thermal comfort. To do that, we need legislation is one option. The EU creates an important directive called Energy Performance Buildings Directive, called EPBD, and the first version came in 2002 and is the Directive 2002/91 EC, European Community, and the main principles are required building regulations in member states, because in that time some member states don't have regulations in energy sector for the buildings, and also introduce the energy performance certification of buildings. Now in Europe, in most countries, when you want to sell a house, you need to tell what is the label, like also a car or electrodomestic, like a freeze or something. And also the house, you need to have a label. That is because the implementation of that directive. And also use the renewables energy, increase the use of the renewables energy in buildings. A second version of this directive came later in 2010. It focused in two main principles: the principle of nearly zero energy buildings, the ZEB, and also a cost optimal levels of a minimum energy performance. The member states must transpose for the national legislation this directive. The situation in Portugal. In Portugal, in 1991, we have the first the first energy performance requirement for residential buildings in that time. There are significant difference, if you can see the significant difference in buildings built before that date and after that date. After this regulation, usually the buildings has for the external walls a double pane of bricks with insulation in the middle. Before that, they could have or not. After that, most of them they have. Also, in 2006, we improved these codes, and also we extend for the non-residential sector, because the first codes was mainly for the residential code. Also, we did the transposition of the directive in 2006, the EPBD directive. This EPBD directive is more for non-residential buildings. The second directive is also for the residential and non-residential buildings. In 2006, the legislation has two particularities. One is the obligation of use of solar collectors for domestic hot water in all houses. So since 2007, about that, all houses in Portugal must have solar collectors for domestic hot water. They have a few exceptions, but they have to change to other renewable energies if you don't have a solar exposition, for example. And also, they have other particularity that has inspections for the indoor air quality. We impose inspections for indoor air quality for the non-residential buildings, but suddenly we should abandon because most buildings can't comply this obligation. So the legislation was, the standards are so high that we can't comply. So the solution is don't forget the legislation. Later, in 2013, we made another codes that mainly for transposition of the second directive. Also, in that time, we changed the methodology of the calculation, the energy in the buildings. Now is based in the reference building for comparison to the real building in the base case scenario. We have two buildings and we see the solutions, the best solutions, that is a standard solutions that is a very high standards with a real building. And also the parameters, the parameters can be changed by the year. For example, some parameters start in 2013, in 2016 they increase the parameters. The reference building with these parameters is considered to be the same type as the real building, but with the reference values and without renewable energy. All new and renovation buildings must consume at least the same energy than the reference building. The energy class in this case are the B-. This can show some requirements included in the calculation. For example, the requirements of thermal comfort. When we did the calculation, in the summer, for example, we put the building inside at 25 degrees and in the winter at 20 degrees. Is considered the thermal comfort. Also, they have minimum requirements for the overall heat transfer, including thermal bridges, columns, beams, and so on. A solar factor, a ventilation, and also a maximum energy needs and primary energy consumption. Also, we have requirements for the system efficiency. for the systems, for the heating, ventilation, and for the HVAC systems. For example, for you have an idea, the E1, E2, and E3 is the three climatic regions in Portugal. Basically, the south, the center, and the north. For example, in Faro, for the walls, a minimum requirement is 0.5 watts per square meter per Kelvin. That means that to do that, we need at least 60 centimeters of the insulation. Depends on the type of construction, but at least 60 centimeters of insulation. And also for the roof and the floors, we need at least 100 centimeters of insulation. 100 centimeters, on the past we still put in some freeze cameras to have an idea. And also we have the factor solar value to for the windows, for the sun don't heat a lot the house in the summer. We impose some ventilation because the houses need to be ventilation, and we impose the renewable energy systems, a minimum contribution of the 0.65 square meters per occupant. This is compulsory for the new houses. Also, for the technical systems, for example, for the cooling and heating, if we cool and heating and doing the domestic hot waters by heat pumps, we need at least have these efficiencies. The Eurovent was the organization, an association that gives the methodology to test these devices, and this is the efficiency that we should use. Also, for the other systems, we can see, for example, the fans, the case of the fans, and the electrical motor of the fans should be at least the class of IE1 or IE2, and a minimum specific fan power and a minimum specific fan power of now is less. It's about 2 kilowatts per square meter per cubic meter per second. Also, the lighting, for example, the office, they are defined the local for the schools, for auditoriums like that. They have a minimum, for example, for the office, a 2.5 watt per square meters per 100 lux. In fact, is easy today with the LED technology to do that. The energy performance certificates is included in the energy codes. It's compulsory since 2007 in Portugal, and the ADEN is the organization, a Portuguese organization that manages the systems. They have also a qualified experts, are the only persons allowed to issue the certificates. If I want to do a certificate of my house, I need to contact a qualified expert, and the qualified expert should be an architect or an engineer with at least 5 years experience in building energy sector, and this is important, an exam for do that. The ADEN manage these exams. Also, the certification is compulsory for new buildings in the project phase. So when you do a project, we need a certificate for the project, and also at the end of the construction, also we need another certification. Also is compulsory for the existing buildings for rent, sales and refurbishment. Is an important source of information for consumers, give recommendations to improve the label. The energy label has been used by some municipalities to reduce taxes for most energy efficient buildings and also to apply and receive public financial incentives. The EPC has been a key driver for success of the energy strategy in the building sector. Only for you have an idea how can we classify the building. We have eight classes of the building. This is the B-. The class is a ratio between the energy of the consumption of the reference building and the real building. This is for the residential and non-residential are the same. For the residential, if you have a class, if this ratio give you a number of 1, that means your building is similar to the reference and is a B-. And if they consume less, you have other classes. To do this calculation, we have 3 main members. The first is the heating. We can see the energy of the heating and the systems, the energy needs for the cooling, and the energy needs for the domestic hot water. We do that for the building, real building, and for the reference building. Finally, I can show you an example of an EPC. EPC has usually 8 to 10 pages that describe the walls, the ceiling, describe the ventilation, all things I have said. And in this area is area related to the building, the information about the building. This area is the information about the label, and this area is about the information about heating, cooling, and domestic hot water. For example, in this building, they have a label of A, and is in the heating is 77% more efficient. Okay, 77 more efficient than the reference building. Could be, for example, in the heating A+. Why? Because this building has a biomass boiler. A biomass boiler is considered renewable energy. The cooling is 34% more efficient. They don't have systems to cool, but they have a nice windows and a nice and a good shadows. And for the domestic hot water, they are 64% more efficient because they have solar collectors. This information also is interesting because give you the losses and the gains of the building, where the building has the losses and the gains. You lose, for example, for 31% of the energy needs for heating the building, 31% is for the ventilation. Is for the ventilation. 10% is about the ceiling, 31% about the walls, 5% about the basement, the pavement, and 23% about the windows. This is the needs of the heating. The gains in the summer, the gains of the building is basically through the ceiling, through the walls, and through the windows, and also to internal gains due to illumination and the people inside. And thank you.
Okay, thank you. Now I invite the speakers to join me at the table, and we open a session of questions. Okay, so any question? Oh, first question there.
Yes, first I want to say how impressed I was in these talks with the way that we've integrated the considerations of energy efficiency with environment, climate, and so forth. It's very impressive. I still had the sense that something was missing. For example, when I look at the sign we have up here, healthy earth, healthy food, healthy people, and I was wondering how much the consideration of the health of the public was being taken into account. So, for example, we saw push bikes, electric cars. Seems to me those different options would have significant impact on the public health, as well as on land use. So, for example, parking for these kinds of elements. So even though we have integration, for example, the Sevilla presentation, we talked about the EU goals, the targets, for example, technology, but I kind of have the sense that we have a bias towards solutions that involve new technologies and high technologies and that have some economic promise. Because if we have new innovative solutions, then that provides employment. But that some of this bias might be working against us in terms of health and landscape and ecology. So I'd just be interested in your comments on these issues and how you were considering them in the programs that we've seen being implemented.
Is that working? Okay. I think that's actually we were talking about with Anna last night about something that's related to this, in the sense that we go more for technical solutions sometimes and for kind of boosting the industrial and economic effects of these policies that actually make them integrated and having the whole picture. That's why we think it's so important in the way that the objectives, the political objectives of the European Union are being defined for the next period and how those are going to be implemented. Because it's going to be forced, at least related to urban policy, for you to show, in order to get funding from the EU, it will be a force for you to show that those have clear effects and are really integrated with other policies. As we were saying, now the strategies that we are implementing has to show in which way actions related to mobility or to how you choose actions on those fields, on the energy efficiency, renewable energies, or mobility, are connected to reduction of poverty, social cohesion, revitalizing and conservation of natural resources and landscape, and also in which way this is connected to the people, not through administration, so probably through the local level, especially because we are talking about urban strategies. So I think we are going in the right direction, but sometimes we get trapped somehow in those sectorial policies and technical solutions for those sectorial policies without missing the big picture about that. I don't know if I explain myself. But.
I can add something, saying that I appreciate very much the comment that we are aware that what we do concerns many different fields and viewpoints, and and observations that it's impossible to describe in 15 minutes, but the comment was perfect. I think, first of all, that dealing with the solutions, like for example in the case of carbon footprint mitigations, the first recommendation concerns human behavior. We have to change our behaviors, and our behavioral change concern energy in households, concern mobility, but also concerns food and our daily life. In the model I presented, there are just a few of these aspects, and then most of them concerns with energy. But for example, what would happen if I add the impact of food production chains in my model? In that case, the carbon footprint that I represented would be probably double, because the impact of food is much higher than we expect. And so the choice we make in terms of food, like for example our dietary attitudes, can really change the world. For example, when we eat meat, I love meat, I like meat very much. But the point is that we should not eat meat every day. We should eat less meat, like once a week, 2 times a week. The impact in terms of greenhouse gas emission of an hamburger is like 12 kilometers driven by car. One hamburger, 200 grams of hamburger is like driving 12 kilometers in terms of carbon emissions. And I think that the option we have is to eat meat, maybe, if you are not vegetarians, but once a week, and choose high-quality products. Because usually when we deal with short production chains with food, we have seen through the life cycle assessment of food, for example, that the impact is quite low, even 50–80% less than conventional food we find in supermarkets that comes from the food industry. So our behaviors can really change our life in terms of healthy, in terms of environmental impact, and in terms of well-being, I think.
So, another question?
I have 2 questions, one for Josefina and Tanya, one for Antonio. Josefina, when you presented and you brought in the SDGs, I was wondering how much, because the SDGs are so general in many ways, and did you take those SDGs, were these SDGs taken and contextualized for the context of the study? How much was it integrated with those CCAPs? I forgot the abbreviations. So what is the interface, and to what extent is that interface? That's the question to you two. And then Antonio, are any passive building design strategies integrated in these regulations or these assessment of the sustainability or the efficiency of these buildings? Because it seems to me there's a strong focus on the technological dimension, and I think this also responds a little bit to Dr. Farid's point, is that a lot of this can also be administered through some passive, architectural passive design, either for older building through retrofitting or for new designs of building by really either locating them in a specific way, creating the openings in a certain proportion, putting vegetation outside to shade, and so forth. So these are.
So I answer first. In fact, directly, the passive question are not related, but indirectly, we can see passive solutions. For example, when they can influence the area of the windows, and you can do the area or the orientation on the windows. So indirectly, you can design the passive, and the energy that the building needs are less. So, but directly, I agree with you. Is to look at focus in the technology.
There is no encouragement regulation-wise to actually push towards passive design or sustainable design in that sense.
Well, the sustainable designs is one thing. They are not. They are more related to energy than sustainable design. But unfortunately, they don't have directly rules for the passive buildings. Directly, no, but indirectly, yes.
Even though. No, I would like just to add a little bit of what Antonio said. Even though there are limits for example, the transmission coefficients in the walls and things like that, that forces the constructors to use a more passive design in the sense of the isolation, for example.
But I mean, there are, like, you know, at least from the landscape perspective, for example, there are parts in Europe and Germany and so forth where there are incentives, for example, to create more pervious surfaces and less impervious surfaces through reductions of either real estate taxes and so forth. I mean, if it is followed up with, because you know, it's not only just the opening of the window, it's the way you locate the building,
exactly,
orientation, and blah, 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 other things before I actually start, because you can save so much by really looking at the building as part of the landscape in many ways before you actually start looking at the wall thicknesses or the U values or the coefficients that we're talking about. So I'm just wondering if there is something in parallel.
Yes, it would be a good idea. We don't have it. We don't have it. Yeah.
But I mean, it would be interesting to see if there is something in parallel to that actually can support it, not only just energy reduction use or working with sustainable dimension.
Here I will give my comments. First of all, I really admire that we have a legislation starting from 2007 to have an energy efficiency evaluation or assessment for housing, and that reflects on their price and to whatever. This legislation, I think, refers to something or relates to the passive design in architecture and landscaping and urban developments, because when you reduce it, it reflects to the, by law, you have to take the, I don't know, authorization or the categorization of the energy efficiency that reflects how much energy you are saving or you are spending. So it encourages indirectly the passive design, passive energy design. Thank you.
A big step forward in that sense in the whole of Europe, in all EU countries related to that. In relation to what you were commenting before, Yasser, the thing is that we have, I mean, we can ask to the OD as to the principles that are established in a certain moment more than actually they are elaborated for. I mean, they are supposed to establish the context, the path, and is our ability as in the case of the EU and in our case at the national level and at regional level to implement, to go towards that direction is the framework. In our case for the SEAP, which are the Sustainable Energy Action Plans, they were built based on the 2020 EU strategy, and it has been definitely a step forward. It has helped more than 80%, for example, of municipalities in Andalusia to improve their behavior, which because the behavior is not just because of the people, it's also people are the ones forming the administration, and savings and consumption, the type of actions that the money is being put in. So it has that instrument has actually have a real impact in people's life, and in the administration, which is one of the highest consumption bodies. So that's the case. It's up to us. I think it was one of the speakers before, he was saying, this is not just plans. We have complied with our objectives. In the case of the Andalusian energy strategy, the objectives that were set up has been achieved. And those have been achieved through money, investment, and actions. So yeah, it's not just plans, it's principles. You cannot, at the international level, I think it's as far as you can go. But you are setting up the path that has to be developed at continental level, in our case, at Mediterranean area, in ours too. And then each administration, in relation to the institutional level, has to take the responsibility to implement that into actions that actually allow us to achieve those objectives. I think that's in the way that it has to work. If you don't do it, if you don't do any actions, then of course it's just paper, it's wishful thinking.
Maybe I start over there. I think I saw it first. That's okay.
Thank you for the nice presentations. In fact, I would like to ask about like classifications of the building according to their energy consumptions. Since we are now currently conducting such classifications in Jordan, I am personally with also my graduate students. So I would like to ask you about when you presented the classification from like A+ or so. Maybe in Portugal you have different also regions, and in each region you have different climates. So what is the benchmark that you have taken to like classify this system as like A+ or B, or maybe in summer or in winter, or did you take the energy consumptions for the whole year? So this is the first point about the classification. Second point also I would like to ask about, what do you have a system to monitor such like implementations of like energy efficient building? How did you measure it? So do you have like a third body that can come to the apartments and knows that this is like energy efficient apartment, or how we can achieve this monitoring and implementation of this?
The benchmarking in Portugal about heating, cooling, or domestic hot waters, we need more energy, we spend more energy to heating, usually, more than cooling, even in the south of Portugal. Related to how to monitorize the energy, for the residential buildings, we don't monitorize, but for the non-residential buildings, I don't explain, but we need to do an audit, an energetic audit to do that. And in that case, we monitorize the consumption. After, for example, a new building, after 6 years, I give a level of this building, and after 6 years, I need to do an energetic audit and to look and to check the energy that the building are spent. And also for the existing buildings, the way for give a classification or to give a level is based on audit an energy audit. So I can go to the building, I can see how much they spend in lights or in the air conditioning in that conditions. So in that way, this is the real consumption for the non-residential. In residential is difficult. It's based on standards. I standard that the house has 20 degrees. My house, I don't have systems. They say that the house can spend some amount on energy to heating, but I don't have the system, so I don't spend that energy. My house is not at 20 degrees, probably in the winter they are at 19 or 18, but I don't spend the energy. My neighbor, for example, could have a system and could have the same label and heat the house at 20 degrees or 25, for example, because he wants to become more hot, and he spend more energy. And the label are the same for me and for him. Unfortunately, we can check that questions.
So,
small comment here, but, if you allow me, because
we are running short of time. Okay, make it small, please.
If I want to purchase apartments, so I should have like a system that allow me to maybe purchase like energy efficient apartment or non-energy efficient apartment. So I want to check that if this is like has 10 centimeter insulations or maybe 3 centimeter thermal insulation. So I think that should be like a system. At least I know that in Germany they have such a system. Might be still, at least in Jordan, we don't have such a monitoring system to check maybe the energy efficient building or the efficiency in the building. Thank you.
Maybe I can, that's exactly the objective of the label. The label tells you that when you buy the house, tells you what is the efficiency, the theoretical efficiency of the house. Then you can do whatever you want with your house. If you want to heat it up to 30 degrees, well, the efficiency is less. I mean, you spend more energy. So we are running short of time. Maybe we have just time for one more question, and it would be over there.
Yeah, and the regulations, there is a difference between residential and non-residential. What's the percentage of non-residential? Does it worth it to have such a difference in the regulations? And are they investors or?
The difference is because the using of the buildings and when in the residential we use the same kind of energy in our residential, we all use the same. In the non-residential could be a school, could be a pharmacy, could be other kind of building, and is totally different the energy that I spend in the school or that I spend in the office.
What's the percentage?
What's the percentage of the analysis? They are much more residential buildings. In terms of the EPC, we can tell only 10% of the EPCs are for the non-residential. Most of EPCs is for residential. It's more complex to do that in non-residential, and also is compulsory in both cases, but you sell much more. You don't sell this house, this school, so it's not supposed. But you sell the house. When you want to sell the house, you need to have so this is the driving force to do. But I can tell you, 10% of the non-residential.
So we are running out of time, so I know there are many questions more. I ask you please to ask it during lunch, okay? And thank you very much. Applause for all the presenters.